Hello, this is Mr. Kenzie's Integrated Algebra Review, Day 17. We're going to focus on solving quadratic word problems using consecutive integers as well as shapes. So starting off with number 7, the one that is circled. The length of a rectangle is 4 more than the width. So in this case, we have to have the width before we know the length. So when we draw our picture, I'm going to use the width as W. And because it's 4 more than, we know more than is addition. So this would be W plus 4. Now it says find the dimensions if the area is 77 meters. Well, area is the inside. That's 77 meters squared. So we're going to use the area formula. So we have area is equal to length times width. We're going to plug in 77 for the area, the length, which is W plus 4, and the width, which is W. You can reverse this equation if you would prefer. So now I'm going to distribute, bring down 77, distribute here to get W squared plus 4W. And then I'm going to subtract 77 to the right. You can move the other two terms to the left, but I just like dealing with a positive A value. So now we have this quadratic. It might be a good idea to use your calculator and plug 77 divided by x into the y equals. So what do I mean by that? Just for review. And when I do it and push second table, I'm going to get all of the factors of 77. So I need to use the 2 that will give me a positive 4. So that's going to be 7 and 11. So I have 0 is equal to, so 2 sets of parentheses, W, W, plus and minus. I have a positive 11 and a negative 7. So we t-bar. Here I will get W is equal to 7. Here I'll get W is equal to negative 11. Now, we're talking about the dimensions, the lengths of the sides of a rectangle. So we can't have a negative dimension, so I reject this one. And I'm going to take the 7, I'm going to plug it in here. So W is equal to 7. W plus 4 is equal to 11. So that would be my answer. Please take a look at the next page. Number 8, we are going to set up. This one says, the sides of a triangle are consecutive odd integers. So they're consecutive odd numbers. So that'd be like counting 1, 3, 5, 7, 9, 11, and so on. So no two numbers are the same. So because they're consecutive odd, we have a triangle that will have 3 sides that are not the same. Consecutive odd, well, here I'll have x. We then have, to get the next consecutive odd, so if I had the odd number of 11, the next consecutive odd is 13. To get from 11 to 13, we're going to add 2. Then the next one would be x plus 4. No matter what, if you're talking about consecutive even or odd integers, you're always going to be adding 2, then 4, then 6, because it's the distance in between. Now it says find the lengths of the sides if the product of the smallest. Well, the smallest, I'm adding 2 and adding 4, so this must be the smallest. So the product is multiplication. The product of the smallest and largest is 21. So you'll solve that, and then you will reject the negative once again because we cannot have a negative length. I'm going to take a look down here. You're arguing number 9 on your own. Finish up number 8. Do number 9 on your own. And look at number 10. This says find 3 consecutive negative integers. So our let statement will be let, and we're talking about 3. So we know something will equal the first consecutive negative integer. We know something will equal the second consecutive negative integer. And we know something else will be the third consecutive negative integer. Now, consecutive negative integers. That could be like -5, -4, -3, -2, -1. So they're just increasing by 1. So the first one's going to be x. It doesn't say anything about even or odd, so it's just adding 1, then 2, and so on. Such that the product of the second and third, so now we're using the second and third. So we have x plus 1 times x plus 2 is 20. Now we're using these, but it's telling us to find 3. So when you're done, this is one you're actually going to have to reject the positive answer. Makes you FOIL, set everything equal to 0, factor, t-bar, and solve. So you're going to finish number 8, do number 9 on your own, finish number 10, and then you're going to do number 11 on your own as well. Thank you.